Hello everyone, I'm Thinking Tree, and today I opened this live stream to study for my final. And today I was supposed to open like 20 minutes ago. However, after coming back from academy, I was so hungry I had to eat something, so that's why I opened it quite late today. And so today is Wednesday. I finished my English midterm. Yay! I mean final. That's good. And uh, I have math and science left, so I'm playing. I don't. I did not bring my science textbook because I prepared it 1 week before the exam, and also I will have study hall tomorrow. So I think I just have to take a quick glance at it one more time tomorrow. So today I will only focus on science. And so today I will finish writing the paper for chapter 12, and then I will quickly explain about chapter 11 because I did chapter 12 last time. It's pro. As I said, sorry, as I said, I think I wrote until chapter 12, and uh, now I'll quickly review chapter 11 because I heard that and learned that explaining is the best way to actually learn and master the concept. So I think I'll quickly go over chapter 11 now. Oh wait, why do I feel like I did chapter 11? Yeah, no, I don't think so. Oh, did I do chapter 11? Maybe I did it for kids, maybe. Or test. Chapter 11, it is about, I'll just quickly do it because I need to sleep early today. It's about motion, and I'll just quickly point this one. So chapter 11 is about motion, and there are three subsections which are distance and displacement, and the next one is speed and velocity, and lastly, it will be about acceleration. Acceleration. And so first, chapter 11.1 is about distance and displacement. And before I go over about that, there is a thing called frame of reference. And frame of reference, so is a frame of reference. It's a system of objects. It's a system of objects that are not moving in relation to one another. So, for example, when I am in a car, then my frame of reference can be a tree that is in outside because it is not moving, and I need frame of reference to fully describe emotion because if I say moving 1 kilometer per hour, then is it 1 kilometer per hour compared to the car that is moving next to me or compared to kind of things that are not moving? And so that's why we need frame of reference to fully explain emotion. And relative motion, that's why it's a movement in relations to a frame of reference. So, then usually when you just say you're actually moving faster than the speed of a bullet because the earth is moving that quickly, and obviously it's very useless to think about that speed. So we just usually when we choose frame of reference, we choose it in relation to the ground. Next one is about distance. So distance is the shortest length between 2 points, and this placement is a uh, it is not it's quantity something measure quantity, I think. Yes, so we can only measure distance, and the SI unit for distance is meter, and displacement is distance plus direction. So when you describe about the direction in which you're heading for the distance, then it becomes displacement. So one example is since displacement is a vector, so vector is a quantity that has both magnitude and direction. Vector is usually a resultant vector. So when I look at a thing that travel like this much, I will say this. Mm, Let me just say it like this. Then when I say this as 1 kilometer, then the total distance I travel from here to here is 1, 2, 3, 4, 5, 6 kilometer. The distance is 6 kilometer. However, it becomes different when you think about displacement because it's a result of vector from here to here. So here is 2 kilometer, here is 1 kilometer. So we know that by using Pythagorean theorem, we can get this, and it's not plus or minus because the length is always positive number. So in this case, the displacement will be square root of 5, which is about 2.2 something. So it is about 2.2 kilometer, and then it is northeast, so we can say northeast. So this is the difference between distance and displacement. Uh, then also there's another example. If I travel 4 kilometer this way and 2 kilometer this way, then the total distance that I traveled is 6 kilometer. However, the displacement is here to here, so the total displacement I traveled is 2 kilometer to the east. The next section is about speed and velocity. Similarly, velocity is a vector quantity and speed is not. So speed is the change in time, is the ratio between changing in distance and the changing in time. And uh, and speed, so that's why speed is usually represented as this equation. I think in math you usually use R, but as rate, but in science I think you use S. So we usually use this. It's changing in distance over changing in time, and usually in this case we're thinking about average speed, and there is two types of speed, which is average speed and instantaneous speed. And so when you usually look at the speedometer that's in your car, that is actually telling you the instantaneous speed, which is the speed that is measured in a certain is in a given time. And average speed is just um like the normal speed that you think. So the total distance over total time. I will just say this as total and total time. This is the average speed, and uh, there is a graph that I want to talk about. It is about a distance time graph. The distance time graph. So for distance time graph, the x-axis is time, and the y-axis is distance. And um, do you speak only Korean and English? Or are you studying another? For me, I am also learning Chinese. I'm not good, but I'm trying and I'm learning. Uh, so in this case, when I can draw a few types of graphs, but I want to talk about the second graph later when I talk about acceleration. So when there's a graph that looks like this, uh, why do I want to mathematically describe it? Like y is equal to, I want to do it, but I think I can do it. So it is. I mean, usually we don't do this in science, but I just love math. And if I say, when I say like this, it is 1 from x is 2, and it is x again, x plus, no, x minus 1 when it is 2 to 3. Yes. I don't think this is really necessary, but I mean, I think it's very satisfying to uh, use math to describe the function. Anyways, this is not related. And in this case, we can know that the speed is constant in here because um, the slope in distance time graph represents the speed because slope is changing in y over changing in x. So it's changing in distance over changing in time, which is equal to speed. So the slope represents the speed of an object. So in this case, it's a straight line, which means the slope is constant, and therefore I can say that in here the speed is also constant. However, in this case, even the time passed, the distance is not increasing. Therefore, I can say the speed is 0 in here, and later I can say the speed is increasing. But when it goes like this, the speed is decreasing. And this is how we graph it. And uh, uh, velocity is just a vector, and velocity is speed plus the direction. And yes, that's as I explained about displacement. Velocity is a similar thing, but it's just distance being replaced by the speed. Now the last section that I want to talk about for chapter 11 is about acceleration. And acceleration is the rate at which velocity changes. So acceleration occurs when speed changes or direction changes, or both of them change. And usually the acceleration due to Earth's gravity is 9.8 meter per second squared. So it means for 1 second, I mean, I think I can draw a graph like this. I'll say this is time and this is velocity. And assuming that we are on Earth, it is when the time is 0 is 0 meter per second. I'll just say second. When it is 1, they will be 9.8. When it is 2, it will be 19.6. When it is 3, it will be 29.4. Yes. And this is and we can keep going. And this is called a free fall, which is and the movement of an object towards Earth solely due to gravity. And constant acceleration means it is accelerating in constant. It's a steady change in velocity. So the acceleration formula is equal to changing in velocity over total time, or so it can be usually explained as the final velocity minus the initial velocity over total time travel. And now lastly, I would just want to quickly talk about the graphs. So there are nonlinear and linear graphs. So for linear graphs, it's linear when the plotted points make a straight line. It's nonlinear when it is not straight and maybe curved. So for acceleration, we use speed and time graph. So it's time in x-axis and speed in here. So when it's like this, it is steady change in speed, so which means it is constant acceleration. However, when it is like this, the speed is constant, and even the time is passing, which means the acceleration in here is 0. Now, when I look at the same scenario and distance time graph, I need to have like quadratic function like this, or something that looks similar in order to have acceleration. Because when I pick 2 points with intervals like this. The slope in here and here to here to here to here to here is increasing, which means I can know that, and if they're steadily increasing, then I can say it is constant acceleration. And in this sense, time graph, it must be nonlinear in order for acceleration to occur, while it is okay for speed time graph. It is okay for speed time graph to have linear line or graph to explain acceleration. And instantaneous acceleration is how fast a velocity is changing at a specific moment. So it is similar to instantaneous speed, but it's just acceleration at this time. I think today I finished reviewing for chapter 12 and chapter 11 for my science, and to I will quickly read Bible and adjust my schedule for my final that is happening tomorrow too. I just wrote First Samuel chapter 8, and it is about because Samuel became old, Israelites wanted new king. However, God warned them that it is not Samuel that the Israelites are rejecting, but God. And God said the new king will just rule over them. And even though God warned them, like um, because, as we know, Israelites they are very stubborn, so they did not choose to listen to God and set idols. And I think that is what's happening this time. Oh, the verse that I just wrote is Proverbs chapter 15, verse 19, which is, "The way of the sluggard is blocked with thorns, but the path of the upright is a highway." So I think I should not be lazy, especially this in this finals week, and I should try to be upright in order to be um, running and flying in a highway. Thank you so much for staying here together. And um, tomorrow, I think I will be opening earlier than usual, so like 9:30, I think. And please pray for our final exams. And thank you so much for being here together. Then good night and see you tomorrow.